Hello everyone. So today we are going to discuss and today we are going to start with our new chapter, chapter number 4, that is determinants. Okay. Now see, what happens here is this chapter is completely related with chapter number means our previous chapter that we have studied, that is matrices. Now how it is related, that I will tell you, right? Suppose we have system of linear equations. Suppose we have system of linear equations, that is a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. ये हमारे पास लीनियर इक्वेशन है. दिस वी हैव लीनियर इक्वेशन. देन यू नो दैट वी वर राइटिंग इट एज in a form of matrix. We were writing this as, see, remember this is a matrix, right? We were writing these two equations as in this form. We have seen this in matrices chapter. Okay. Now, this is having a unique solution. This system of equations is having unique solutions. What that solution is? a1 b2 minus a2 b1, right? This is a number, you write it, it is a number which determines the uniqueness of a solution. ये एक नंबर है which is determining the uniqueness of solution, and this is associated with, see, what I have told is we are going to start a new chapter, that is determinants. Now in determinants we have, suppose we want to understand what is determinant. So how we will understand? You have to assume there are two system of linear equations. These two, 1 and 2, right? Now we can write this in this form, in form of matrices. If you want to write a1 a2 b1 b2 x y and c1 c2. Don't worry if you are not, means in matrices chapter you are not able to recall. Right now you see over here, okay? Now, this is having a unique solution, that is a1 b2 minus a2 b1. Now, how it came? How it came means it came from this matrix. It is associated with this matrix. It is a number which determines the uniqueness of solution. Okay, you have to remember this right now. Okay, note it down in your book, everyone. Okay. Now, we have the chapter that is determinant, but I have wrote about the matrix. But here what I want to tell you is that this is a1 b2 minus a2 b1. Okay, this is called determinant of what? a1 a2 b1. Okay, I will tell you with the example. Okay, but right now you just remember this is called determinant. कैसे लिखते हैं उसे, how we are writing and what to write, I will let you know. Okay, you just note it down, so I will erase this. Okay, you can take a screenshot and later on you can note it down, right? Now I will tell you that Determinant is written using two straight lines. Determinant we will write here. Suppose we want to write a determinant a11, a12, a21, a22. We can use symbol delta or we can use any other symbol also. Okay, so this we can say determinant. अब अगर determinant को matrix बनाना है, we can write it like this. This is a matrix. But determinant is not having this sign. It is having two straight lines. Okay. Another important thing which I am going to tell you is it is having only square. Okay. Here we cannot say 1 by 3, 2 by 3. It will not be able. Either 2 by 2 or 3 by 3. Okay. So here in determinant we are going to have only square matrices. That is only determinant. Right. Now I will tell you one very simple thing for determinant. Right. Suppose you have one matrix A. Okay. I will tell about determinant. Determinant is applied to every square matrix. You have to note it down. Okay, determinant is applied to every square matrix if A, there is one matrix A, right, capital A. If it is A, B, C, D, okay, which is a 2 by 2 matrix, right? Now, if a matrix A is A, B, C, D, it is 2 by 2, then determinant A, we can also write determinant A like this way. We can write delta, we can write A. Okay, see, we can represent determinant in this way. Okay, it will be A, B, C, D. We can represent determinant like this way, right? It is also called determinant A. We can also write DETA. We can also write delta. We can also write A. Then mode of A means n is equal to A, B, C, D. So right now, what you understood, that is a square matrix means determinant is applied to every square matrix. Okay, determinant is always, it is a very compulsory statement, that is it is applied to every square matrix. Suppose you are having a determinant A is equal to A, B, C, D, which is a 2 by 2. Okay, it is a square matrix. So we can write determinant A as DET, then A, delta or any letter, then this mode sign is equal to, we have to write these two straight lines. Okay, these are called bars, A, B, C, D. So this is a determinant. Right. Now I will tell you one remarks. I will tell you two remarks. Okay. Remarks. Right. First one. That is, for matrix A is read as second thing, only square matrices, only square matrices have determinants. This is a very important thing for us to remember or to get the knowledge about determinants, right? So I hope so this much is clear with everyone, right? Now you can note it down in your book, okay? After this we are going to see determinant of a matrix of order 1, right? So I am erasing it. If you have not noted it down, then you can take a screenshot of this and you can note it down, right? Now I am going to write that determinant of a matrix of order 1. Determinant of a matrix determinant of a matrix of order 1 of order 1. We are going to see this determinant of a matrix of order 1, right? Suppose that, okay, suppose or let matrix A is having one element only, which is A, okay, be a matrix of order 1. Let A is equal to, this is a matrix which is having order 1 and the one element is small a, right? Then this, if we want to write determinant, then its determinant is A only. Means in short, here if it is small b, then here it is answer is small b. Here whatever is your element, that is the same answer for order 1. Okay. So what you have to remember, that is for order 1, whatever is the element of matrix, that will be a element of, that will be the value of determinant. Okay. For order 1 only. I am talking purely for order 1 right now. Okay. So after this we are going to see for order 2. Okay. So first of all, you note it down, right? Now I will talk about order 2. Determinant of a matrix of order 2. Now what will be the condition in this case? If the order is 2, then what will be the condition? Right? Suppose that A is equal to A11, A1, A21, A2. Right? Let this be a matrix of order which is 2 cross 2. Right? Then its determinant, if you want to find its determinant, see right now I am writing all the symbols, okay, but because it is just an introduction part, but in exam or when you are writing, I am writing for your knowledge. In examination no need to write all these three. You can denote determinant by any one of these, right? So it is not compulsory. Here if it is given capital A, you also write capital A. If it is given capital B, you write here capital B. Okay. Now, then determinant, what will be the answer? See, in short, I will tell you what you have to do. You have to multiply this first. A11 with A22. A11 with A22. Then you have to multiply these two. Cross. A21 with A12. In between you have to put minus sign. That's it. See, this is a very, very important step. What step it is? Listen. Suppose or let capital A is equal to, which is a 2 by 2 matrix, which is having its elements a11, a12, a21, a2. Now what you are going to do, that is you want to write its determinant. So how you will write? You can denote by any one from these three, right? Determinant A is equal to delta is equal to determinant A is equal to, what you have to do, you have to cross multiply this, means you have to multiply these two elements first. Okay, a11 multiply with a22, you will get one answer. Then that answer you have to subtract with these two, multiplication of these two, a12 with a21, or you can write a21 with a12. Anyways, multiplication is commutative, so we will get our answer for determinant, right? So this was the introduction for determinant. Now I will tell you one example. Okay, suppose you want to find, I am giving you one example. Okay, that example is that first one, 2 minus 1 4 2. We want to find its value. Same way on this, right? Your question will be find the value of determinant. Okay, now what you have to do, these two elements here, a11 is to, instead of a11 we have 2, instead of a12 we have 4, instead of a21 we have minus 1, instead of a22 we have 2. So what a11 and a22 means, these two, 2 and 2 we multiply, so 2 and 2 we minus sign, remaining two elements we multiply minus 1 with 4, so 2 2s are 4, minus minus will become plus, 4 1s are 4, its answer will be 8. So this is the value of determinant, that is 8, right? So whenever you want to find the value of determinant, when 2 by 2 matrix is given or 2 by 2 determinant is given, at that time you have to use this method to get the required answer, right? It is very simple. What you have to do, see, whenever determinant is there, so you start from first element, its diagonal opposite element means this, multiply this both, 2 2s are 4, then you have to keep minus sign, multiply this both, 4 into minus 1, answer is minus 4, minus of minus 4 plus 4, 4 plus 4 is 8, that's it. You will get your answer very easy. Now second example, suppose you want to find the value for determinant, that is x over here, then x minus 1, here x plus 1, and here x. You want to find the value of this determinant, that is x, x plus 1, x minus 1, and x. So whatever I explained to you, same thing you have to do, that is multiply these two elements, x into x, keep minus sign, x plus 1 to x minus 1, x into x is x square, x plus 1, x minus 1, we have a formula, a plus b, a minus b, a square minus b square, 1 square is 1. So x square minus x square plus 1, this x square and x square gets cancelled with each other, our answer is 1, right? So this is the solution for your example. Okay, here we have a determinant x, x plus 1, x minus 1, x, x into x is x square, minus sign you have to keep, x plus 1, x minus 1, a plus b into a minus b, answer is a square minus b square, 1 square is 1 only, so I have not written here square. Now minus sign means the brackets are open, so minus and plus x square minus x square, minus minus is plus, this plus x square gets cancelled with minus x square, your answer is plus 1, right? I hope so this much is clear with everyone. Okay, now again I will give you another example. Okay, but in that example what you are going to do, that is find the value of x. Okay, suppose you have question, find x if, see, this condition will be given, 3x x 1, this condition will be given. 3x x1, and here it is given is equal to 3, 4, 2 and 1. Okay, this type of question will be there in your exercise, right? Suppose we want to find the value of x. If two determinants are given, they are equal. Now how to find the value of x? Okay, so here we have to find x. This is already given that these both determinants are equal. So what we will do, we will find its value. 3 into 1 is 3, minus x into x is x square is equal to, so is equal to 3 into 1 is 3, 4 2 are 8, or else I will write this in a more descriptive way, that is 3 into 1 minus x into x, 3 into 1 minus 4 into 2. I hope so it is clear with you, right? That is first step. Now what you have to do, that is 3 into 1 is 3, x into x is x square, 3 into 1 is 3, 4 2 are 8. Now here what will happen, minus x square will go that side, otherwise we can also write like this way, 3 minus 8 is minus 5. Okay, now what we can do, that is 3 plus 5 is equal to x square. So x square will be equal to 8. So x we can write under root of 8, but under root of 8 we can write here root 8 is there, right? Now under root 8 we can write so this we can write the answer, that is 2, because a pair of 2 will go outside, so 1 2 will remain inside. So your answer is 2 root 2. But one thing, plus or minus. Okay, your answer will be plus or minus 2. Okay, so like this way, whenever this type of question is there, you have to solve like this way. So it is very much important, dear students. So everyone note it down. Okay, your question is find the value of x whenever condition will be given, two matrices will be equal. So you have to find it like this way, right? I hope so this question and answer both are clear with you, right? Now I will be erasing this, and we will be doing exercise 4.1. Okay, exercise 4.1. You can take a screenshot of this so that you can note it down. Okay, otherwise if you have written, we will move to exercise 4.1. Exercise 4.1 is there. In this exercise 4.1, we have to find the value of determinant, right? This exercise 4.1, what we have to do, that is we have to find this exercise 4.1. Okay, answer 1. What is our question? That is find the value of determinant. Determinant is given 2 minus 5 4 1, right? This minus 1, this determinant is given, we have to find its value. See, I am not writing that question, right? Because it is same only, find the value. So if you want to find the value of this determinant, then what we are supposed to do, see now I have told you what is the method. We have solved enough examples also, so I will write directly. Okay, 2 into minus 1, your answer is minus 2. Here minus sign, minus 4 into 2, or else for one sum let me write this, 2 into minus 1 minus 5 with 4. 2 into minus 1 is minus 2, minus 5 into 4 is minus 20. So it will be minus 2 plus 20. So our answer is 18, which is plus 18, right? Because bigger number is having plus sign, so our answer is plus 18. Second, answer 2. In our answer 2, we have question, same question, that is find the value. cos theta, right? Sin theta and minus sin theta, sin theta minus sin theta. This we have to find the value. So here don't worry dear students, cos theta and sin theta came, so there is no need to worry. Same thing we have to do, cos into cos, that is cos square theta, minus sin, sin into sin, minus sin square theta, cos square theta plus sin square theta. Our answer is 1. It's very easy, right? So I hope so this both the answers and the questions are clear with you, right? Now here another, in this our second question we have, that is we have to find the value for x square minus x plus 1, x square minus x plus 1, x plus 1, x plus 1. Right, we have to find its value. So what we are supposed to do, that is same method. Okay, here these two multiply with each other, x plus 1 multiply with x square minus x plus 1 minus x plus 1 with x minus 1. Okay, now we have to check whether there is formula or not. Okay, so here you can see x plus 1 will be multiplied with x square minus x plus 1. So here we can do one thing, that is x plus 1 x square minus x plus 1 minus a plus b, a minus b, a square minus b square, right? Now after doing this, what we are supposed to do, that is this is the formula for a cube plus b cube, right? Or a cube minus b cube. You have to remember that. How you have to remember that? That is, we have our formula, that is a cube plus b cube or a cube minus b cube, right? So here what we are supposed to do, that is, see, you can solve it also, okay? But here our formula is there. The formula that we are writing, that is a cube plus b cube minus x square minus 1. Now x cube plus 1 minus x square plus 1. So our answer is x cube minus x square, 1 plus 1 is 2. Right, so this is our required answer, that is x cube minus x square plus 2, right? So I hope so this answer is clear with you. Okay, now see, you can take a screenshot of this. Okay, now I will give you two sums for homework. Okay, you will solve it, right? If you have not written it in your notebook, please note it down so that I can give you the homework. Okay, you have to find the value for the determinant, that is 2, 4, 2, 0. Second, 1, 1, 2, 0. And you will tell me, is there any means if first answer is related with second answer or not. Okay, you will tell me that. Okay, just note it, you have to find the value of both the determinants. First question is 2, 2, 4, 0. Second question is 1, 1, 2, 0. Right? You will solve it, and I hope so whatever we have covered is understood by you. Right? Now in my next video, we will learn about the determinants, means properties of determinant, and see in this video what we have done. We have studied everything about 2 cross 2 determinant, right? So now in my next video we will be studying the introduction for 3 cross 3 determinant and the properties of determinant what we are using. Okay, so everyone today will be practicing whatever is covered. Okay, thank you very much.